So this time I'm going to just talk a little more about the technical implementation of how we actually collect data in our systems, now that you have a little bit of the context from this morning. And this presentation really is on behalf of more of our data science team who've worked with our engineering teams really to develop these systems. But I'll do my best, and any questions I can't answer, I'll have to refer. Okay. Sorry. So this is our sort of data collection loop, our ecosystem of how things are implemented and collected, which I'm not going to go through too much because I think I gave a lot of loops earlier this morning. So I'm going to talk more about the actual data collection section. But I think this is a fairly standard model. This was, in fact, even a template loop on the slide deck with the sort of software development process already outlined within it, and it's really just a variation on that. And talk about our basic tools. Sorry, I'm just actually going to pick this up because otherwise I feel like, okay, that's a little better. So in our feedback loops, we have this cycle, and the data collection really starts at the planning phase of, okay, so who are we going to actually test something on? So we're going to first draw a random sample from our population database. And so that's done. So the whole system of messaging is run off a open source platform that we built for MomConnect originally and have since used on other systems. And that's called Seed. And so then we use a Python wrapper with SQL definitions, and we use SQL to organize our data. And that's where we actually apply our selection criteria. We can then draw a random sample from that database with those criteria. And then we have a choice at that point, depending on our experimental design, whether to implement the random assignment at that point or after entry into RapidPro. So we're very grateful to UNICEF for supporting RapidPro. We use that on top of Seed to implement a lot of our design choices. So when we want interactive content, we then use RapidPro. So Seed is really built just for this scale of robust message delivery, and then RapidPro offers all of this additional functionality on top of Seed. So we upload, for example, messages or surveys onto RapidPro, and the actual sample, so the numbers for a sample that are drawn are loaded into RapidPro. And RapidPro implementation, we've actually found our service design team does a lot of the entry into RapidPro and setting up flows in RapidPro. And the implementation actually has a nice GUI style so that it doesn't have to be engineers or data scientists doing that entry. And then that's where we've done work to build random assignment functions and to allow for different types of sort of block randomization and stratification. And to also have sort of conditional assignments, and where we're going to do a lot of the technical work around the exam implementation. And then finally, we have the messages delivered, either over SMS or WhatsApp. And the RapidPro platform has also allowed us to build data pipelines that link to interactive messaging sequences. So, sorry, this is like a lot of, I feel like in a sense, a lot of gobbledygook of all of the technical components, but I sort of want to give you a sense of how, in a way you have this whole messaging system and it sounds quite simple, and in some sense it is compared to going out into the field and collecting data. But in another sense, it does involve all of these different components that have had to be linked up and have a lot of software engineering work coupled with service design work, working with researchers so that we come along and we say, oh, we want to randomly assign. Okay, what do you mean? In what proportions? What functionality do you need for that? And so forth and so on, all the way down these little details of that feedback loop chain. So we've ended up building all of this functionality into RapidPro, so allowing for interactive messaging sequences and having data codes to store the identities of each message and response. That data structure actually starts getting complex, so there's a whole coding system for that. different assignment mechanisms, as I talked about. The group anonymization is something we've been building onto WhatsApp. So this is where we have messaging that could go to an individual, but then now they can elect to form their own group and invite people into their group, or where we do digital focus groups, and then we're getting data from an actual group, and it's sort of open text data. So again, the pipeline around that is different. We've also built some functionality to distribute airtime gifts, data, and cash incentives on RapidPro. And then some of the output data that we then get is uptake of those incentives and information on message delivery. So we get some message delivery notification over SMS, much more detailed delivery reports from WhatsApp. And then we also get outcome data on message download on WhatsApp. So whether someone actually opened the message and read it, so that's important uptake information for us. And then on WhatsApp, we can also get additional data if we request it, like GPS coordinates. We can't reach into someone's phone and get the GPS coordinates, but we can request it and they can share it and contact information as well. So this is sort of the data collection ecosystem and also the structure that's set up to collect the data within our feedback loops. On top of that, in terms of the analysis portion of the loop, we used Redash to set up a real-time data visualization platform, and the aim of that was really, in particular, to help service designers who are tweaking message services and to actually see what the response to specific messages are right away. Right now we're experimenting with Tableau because the health data that we have are very sensitive, and so security is always an issue. Wherever possible, though, we do try to use open source software. The rapid data analysis, so sorry, I'm again going through the technical implementation for anyone interested, but also to give a sense, so please come back with questions if this is too quick. We use RStudio or Markdown with Git. Basically, this is about automating our data analysis pipeline, and these tools, all open source, freely available, fairly simple to use, have been incredibly valuable. So in the end, because I'm going through it quickly, it sounds maybe more complex. It actually ends up being a very simple, set of code linked to a fixed factorial design, and then we use similar analyses each time. And it actually has sped up the process enormously for these feedback loops and for the data analysis. So although it took quite a lot of time to set up those pipelines. And then finally, the findings, I think, are, as I mentioned in my earlier talk, amongst the most difficult to actually translate those quickly for people to use. And again, the template with our Markdown makes it much easier to quickly produce something that is understandable to non-statisticians, to people who need some translation of what these findings actually mean. One of the things I wanted to talk a little bit about is, we're talking about data everywhere. How do we get the data? And these are all the technology systems we have for getting the data into our system. But someone had the great image yesterday of a fire hose, having a fire hose of data, and the use of these factorial experiments and setting these up on these quick loops, plus the digital focus groups, plus this, plus that. It does have this fire hose effect, and that actually setting up a system for synthesizing on a longer time scale is actually really an also important part of this data collection ecosystem. So formatting and documenting and having good metadata alongside as we collect all of these data has been quite a big work. It's ongoing, so it's actually not finished. But thinking ahead to, after a year or 2 years, how are we going to make sense of things that have been repeatedly tested and sort of look for generalizability, for example, across behaviors. So each of our cycles tests these different aspects of messaging, but they could also be looking at different behaviors like family planning or infant feeding. And so we would then want to look at how it works across. So that will involve meta-analysis across these little experiments and setting up that framework. Another more, there's a lot that we could go into, especially around WhatsApp-based data collection, but from an mHealth perspective, what we thought was maybe a little more generalizable was looking at connections, like embedding links in SMS messages, because I think that's one of the ways a lot of mobile messaging platforms collect data. And so we've done some work finding we can actually generate individual links, and then that allows tracking to the individual level, so we can match our individual participant records to their then web behavior when they connect onto a Mobi site, and using Google Analytics to understand their use of that Mobi site. And then finally, external, we work in a system where there's a push towards digitizing health records, at least in South Africa. But that is not everywhere, but I think the importance of trying to link to existing data collection systems is the point here that is hopefully a usable lesson. So, and ideally to be able to think about that from the very beginning. So we were fortunate that MomConnect, when it was set up, prioritized that interoperability and the connection to DHS and now DHIS2, and then that gives us a connection to other data sets and real world data that we can work with our partners. I think I don't have time to go through the applied examples, but feel free to get in touch with questions. That's probably enough for 10 minutes.
It's okay. Okay, hello, my name is Soji Omisore, or for my English friends, Soji Omisore. I'm going to talk, I'm not as lively as we, right? I'm not as lively as we, but I'm going to talk about practical examples that we can use and talk about the challenges that we have in Nigeria. Just to give you kind of a little more background of myself, which relates to Opolox, etc. I spent just over 2 decades in finance, in banking. 8 of those years with the World Bank on the IFC side, and I was part of the team responsible for the Africa region. Spent a huge amount of time looking for opportunities across Africa, but the challenge was finding, kind of, forget good data, just finding data at all was a huge challenge. So over the last 13, 14 years, I've been thinking about the ability to set up a platform, a data platform that allows, that addresses that, kind of information gap or insight gap. Of course, we know that new tools, new kind of analytical tools have now, and technology have now come into play that allows us to be a lot more efficient. So, if you have that in the context of what I'm going to talk about, I think it's really useful. I'm going to bring it down to, in terms of the use. I think it's a bit. You might find it a bit tedious. I talk about the technology in terms of how we store. I can provide a quick summary whilst I'm doing that, but it's more in terms of providing kind of examples of the type of things that we are doing. So feedback loops. So basically, the Sustainable Development Goals are part of the UN resolution. They were basically adopted by member states and to be fulfilled by 2030. One of them is what you call sustainable consumption, right? But the question is, there's so much information, and how do we use data and feedback loops to address what is happening on the ground, right? In my case, we're looking at specifically in Nigeria and how we can address what we call sustainable consumption. So just to give a kind of very quick summary, it says by 2030, halve per capita global food waste at the retail and consumer levels and food losses, etc. The second part is support developing countries to strengthen scientific and technological capacity to meet more sustainable patterns of consumption and production. So there's a lot of data being generated, right? If we look at a variety of data, we can look at things like, if we start from the left, external shocks, in terms of food supply and demand. You can look at floods, famine, etc. If you look in terms of population density, in the case of Nigeria, has a population growth rate around 2.3%, estimated around 290 million people. So how do you feed those those people. Look at weather, in terms of weather patterns, logistics, how you move products from farm to retail, etc. But there's a huge value gap in relation to the storage, silos, distributors, etc. along the way. And of course, we have challenges in terms of transportation, food production, what type of food is being produced, what quantities, etc. Right? Prices and quantities. Whilst all that information is extremely useful, it doesn't provide us with the granularity to be able to make kind of critical decisions from a food sustainability perspective. So one of the things that we're considering in terms of using market level data as a proxy for consumption for individuals. So we know that obviously consumers at ground level are buying a number of goods and services. So the ability to capture that through data scraping algorithm, right, from the retail perspective, and also we have people in the field, Opolox representatives, who basically use a mobile phone with an app that are capturing kind of data on a basket of goods and services across different parts of Nigeria. So that's one of the things that we do. So how do we now, we have all this information, what do we do with it, right? One aspect that we're considering is actually saying that, okay, look, the ability to understand production and its relationship with consumption. So for example, when I say, does production equal consumption, i.e. utopia? In economics, I've got an economics background, I'm not a data scientist, I just see an opportunity in this area. The reality is that we know that supply does not equal demand or equilibrium, right? That's a utopia, but in reality, in the real world, that doesn't happen. So the second question is production greater than consumption? And if so, there's wastage. What do I mean by that? Does it mean that a lot of food is being produced, but it's been wasted due to failure in price signals, lack of storage capacity? Is food and agricultural products being wasted at the farm level in terms of diseases, etc. Right? And if that's the case, what are the kind of solutions we can use to address some of those? So that's from trying to use data to distill solutions on the ground, etc. And if the third one is production less than consumption, so if that's the case, where is the food coming from? How are people being fed? Is food coming from our porous borders? If that's the case, what is the government doing from a policy perspective and the ability to use data to address that? So from a data analytics and feedback loop perspective, it benefits it provides real-time, realistic, actionable, on-the-ground data, granular data, because it's not high-level macro data, which, yes, it's useful, but it doesn't, from a knowledge perspective, it doesn't give the granularity to be able to make informed decisions. So what we're looking at, the ability to quantify influences. When I say influences, when I talk about some of the different data in terms of population, in terms of weather, in terms of production prices, etc. So the ability to understand the influences of the outcome of interest at any one time, as well as understand the patterns and strength and synergies of association, those are key. But more importantly, I think the last point, what we call the identified de novo influences, is basically the ability to ask questions that we were not able to previously ask because we did not have sufficient information or that depth of information to be able to ask these types of questions. And I think it was mentioned yesterday in terms of using analytics to highlight insights that previously were not seen. So I've talked about sustainable consumption. The second example I wanted to talk about is in relation to cycle-based family planning method. We believe that analytics should be used to answer old questions and also new questions. In the case of Nigeria, Nigeria has a population, as I said, about 190 million people, more than around 55-60%, that's 18 and below. So we have considerable concerns in terms of population growth. family planning reduces unwanted pregnancies, maternal, neonatal, as well as infant mortality rates. And from a CPR perspective, which contraceptive prevalence rate of 21%. The average for lower income, or least developed countries, is 40%. For lower to middle, is around 60%. And Nigeria is way below that. So, what kind of things potentially are we able to do to address that? In spite of knowledge of at least one CP method, more than 85% of men, women, as well as significant resources that have been invested in family planning, progress has remained extremely slow. So what can we do? The barriers to uptake are as follows: lack of knowledge and perception about effective fertility, more likely of using less reliable methods, misconceptions about the use of contraceptives, preventing promiscuity, male partner non-endorsement, that's a key one, limited access to providers, and supply chain issues. And the question is, how can we use data in order to address that? Very quickly, one of the kind of ideas we've been working on is basically from a feedback loop perspective. We have in the middle, you can see users, typically women who basically can provide their cycle or safe day cycle information by USSD. USSD is unstructured and supplementary service data. It's something that's commonly used in Nigeria. It's used for money transfer, airtime purchases. People are very knowledgeable and familiar with it, so you're not changing behavior. So it's not a change. So it's something that could be used, to basically get information from users in terms of their menstrual cycle. The data platform basically ingests the data, and that's where what we call analytics is done, and they provide the safe period for the user. From our perspective, what it does, it allows information from users in terms of usage patterns, demographic demographic data of users, reliability of methods, and cycle knowledge. Beyond that, it also allows what we call communication advertising in terms of sexual reproductive health messaging, using SMS. So that's for example one of the areas that can be considered. So what are the expected outcomes? If a family planning method, where none is currently being used, improve sexual health related knowledge, change in behavior, intervention uptake, and linkage to further care. So the ability to direct users from informal structures to more formal structures like clinics, hospitals, etc. But for the providers of the service, it allows them to basically collect a huge amount of kind of cohort data. And those are things that can extract in terms of users, demographic of users, usage patterns, reliability and acceptance of the method. So those are some of the key considerations. So in summary, right, I've talked about sustainable consumption. We know that it's typically complex, it requires many stakeholders, and you have a wide variety of data. It's not something that can be done kind of immediately. You need to work with multiple partners. From the family planning method, what it does is you can work with a less number of users. The data that is determined by the normal feedback loop in terms of the user input data as well as the output. It's a continuous loop. So that's less complex. But from our perspective, our view is that feedback loops will allow us to, in terms of advocacy, in terms of strategy, and in terms of research, the ability to bring granularity to decision making out in the field, especially in a region or country where there's very little data available. Those are some of the things that we are currently considering. But from a data collection perspective, we first rely on clients who have a lot of data, And secondly, we do a lot of data scraping. We write a lot of data scraping algorithms, and we store them in our Postgres database, as well as we also use open source. And lastly, we also have people on the ground, Opolox representatives, about 8 at the moment, who are collecting data out in the field using an app, etc. So I'd like to leave it there, but I think it gives a kind of overall perspective in terms of how, where, and the use of data in an environment where data doesn't typically exist or is not being captured and analyzed.
Hi everybody, I'm Neal, also less lively than Yui. It's great to get to talk to you for a few minutes about how Dimagi has harnessed data over the years. And it's been kind of gratifying for me to see almost like every stage that I'm going to talk about has been touched upon by others during today and yesterday, so it's a lot of very familiar themes. I hope that doesn't make the talk too boring. And then just for context, what Dimagi does is we focus on equipping community health workers and other types of frontline workers with mobile apps. So as you all probably know, community health workers and other frontline workers have been a really core component of a lot of development efforts for many, many decades, often being the primary point of contact with the population being served. And over the last 10 years, there's been a lot of interest by groups like Dimagi and others to try to further increase the impact of community health programs by equipping the community health workers with a mobile application. And I won't go into too many details, but it's a complement to the kind of direct-to-consumer applications that Ellie and others have talked about, where you're like sending IVR messages or text messages directly to the consumer. We're equipping the community health worker with a mobile application to amplify their work. From the beginning, we started this is a picture I think from 2008 in Tanzania. We also had, as many people have talked about, a very strong emphasis on doing field-based iteration, working very closely with our users. Internally, our mantra was do your design under the mango tree, which we meant as kind of a reminder not to take too seriously all the brilliant ideas we come up with in places like this or in our Boston office, and really very quickly try to get ideas to the field to see how they really, whether the real users like them, and try to iterate with the users to make them useful. And we worked for a couple years with a very small number of users, tens of users, hundreds of users, to kind of figure out where we thought we could add value. And we had a really strong focus at this stage. It didn't feel very data driven. We weren't trying to utilize the data they were collecting, even though we were collecting data. We were really trying to make the applications useful for the worker and make them more effective in their work and provide support to them as they go. And then a couple years later, we really took a strong product focus. And so we built our system is called ComCare, open source system that has a cloud-based system, multi-tenant, which means that different groups can create a project space and then configure it for their frontline program. So in 2012, we had 72 projects with about 2,000 users, and that might look small on this graph, but I remember that it was a lot of heart and soul and sweat and tears that kind of went into supporting those projects. We were thrilled that we had that many. We were more excited the next year when it tripled in terms of both the number of projects and the number of users. And then it did not keep tripling, but we had more and more projects added to our system every year. Some dropped off, some new ones came, some grew, some shrank. And then at this point we were still trying to do that design under the mango tree for each of the projects that we were involved with, but now we had all this data across projects. We wanted to become more data driven and try to harness all this data that we had collected across projects. And I'd say we were modestly successful. We kind of struggled to really find there was only a thin bit of data, a few data elements that were consistent across all the projects. We produced a series of data blogs. We have some internal metrics. This is an example of one that I'll walk you through, which is that we looked at what's the distribution of activity for a set of users of our system, so all the community health workers in one frontline program. And what you might expect is that it'd be a bell curve. From like this picture on the left, it's a bell curve. We found one project that was a bell curve where the kind of median and mean activity is the most, like most people are doing what the median or mean is, and then there's fewer users doing, fewer and fewer users doing less activity, and fewer users doing more. What we actually found is almost all the time it's what you see on the right, which is a power curve, which is that the median activity or the mean activity, the average activity is actually pretty rare, and there's like a small number of, I'm sure there are a large number of users, maybe a quarter of the users who are using the system very little, and then this like long tail of increasingly active users, like some users who are using the system kind of in implausible amounts. And so this is, at least useful if you're trying to like thinking about like how your program works. You might sort of have a bell curve in your mind, and if you're thinking about like trying to improve activity, you might think about like it's the average activity that I'm seeing that I should like think about improving. When really you might want to think more about. Sorry, I think that's on automatic forwarding. You might want to think more about this like quartile of users who are using the system very little, or how to leverage the super users might fit your data more often. So those are the kind of like nuggets and such that we were able to extract from our data. A few others like that. And in 2017, last year was a big year for us. So this project on that, you can see, we had one huge project that got added to our system. So in India, in partnership with the Indian government, with the foundation, many other groups, our system built on ComCare was launched to what is now about 110,000 frontline workers using our system. So that's, a frontline worker covers a population of maybe 1,000, so that's covering a population of about 100 million people. So it's a large project, kind of scaled up. We didn't expect to get to this much scale that's fast. You can see it's like bigger than all of our other ones combined. And just to pause here a moment, one thing that like struck me in the morning conversations is I had the idea that like, a lot of us are focused on kind of that early formative stage, and that like that's where a lot of the iteration and innovation happens. That's where you do rapid feedback and everything, and then it goes to scale, and then that's things are more static. And from our perspective, as Ellie was mentioning as well, like that's where you could like do a lot more iteration when you have scale. And I think maybe it's particularly true of like things that have a technical component and a digital component, because now like Google or not of that level of scale, but like big projects that have all this data, they can use all the fact that there's so many people using their system to run really quick experiments. And so that was the sort of like the thing that we're just now getting to. This launched last year, and we're really getting our heads around this kind of next stage. And so just to say a little bit of what we've done in terms of work at scale, we did once we started getting data, we started doing lots of analyses on different components of the system. It did provide like our team some sense of like what was being used and not used. Although probably the most important outcome of the first analyses was to realize ways in which our data was hard to analyze. So there was like phone numbers that got through our validation constraints that were obviously wrong, and like we have branching logic which would screw up some of our analysis, or it's really hard to figure things out. And so that was really useful because we could then go change the application to like improve the data quality. And until we had started analyzing it, I don't think we would have had sort of like known that these were problems. A second thing that we did that was we found was useful is that when we started sharing reports, certain of them there became a lot of demand for them. We hadn't really seen that on our smaller scale projects as much, but we started just for internal purposes, like tracking who is using our system each day, just like in a very crude way of like creating like a big Excel sheet. Our team started sharing this with some of our external partners. They were really eager to see like where were the areas that were like using it less so they could follow up on it. And now, like a year later, every week we like manually, we have like a big automated dashboard, but like this hasn't been automated yet. But like we manually download the last week of data. We create a huge, like simple CSV file, a spreadsheet that has like 120,000 rows, one for each user. We shared that with our partners. They like process it and compare it a little to last week's version, and then spread it out to the very different groups that are overseeing areas where they can follow up on the regions where people are using the system less to see what's going on. And so that's just an example where like there's no visualization, it's like very crude instance, but kind of it organically developed as an important report just because there was so much need for it. And now if that doesn't get done, like angry emails come in, so it becomes like an important thing that hopefully we'll automate soon. And then what we're just starting to do, like we're hoping to build the kind of like rapid feedback systems that Ellie mentioned in the future, but we're starting to look at hints in our data for like what are activities we can encourage that will have good outcomes. So one of the advantages of our kind of system with a mobile app is that we know what's like every day we get forms describing the user activity. So if we come up with some messaging or something to send out to like encourage a certain type of behavior, like we'll know that day or the next day like whether there was an uptake in it, because we'll be able to like just look at our server and track exactly what the users have done. So we have like the luxury of kind of a lot of data coming in as feedback. And I'm showing this graph here, don't take it too seriously, it's just based on a sample of data, but it's the kind of thing we're hoping to find as analyzing. We now have a lot of pregnancies that we track, for example, and we can, on the x-axis are the kind of what you might think of the outputs or inputs. It's the activity as measured by the form submission of our users. So it's a crude proxy for how much time the frontline workers are spending with pregnant women in their homes before birth. And we can see which, we're just basing on how much time they spent filling out the forms. But and on the y-axis is the probability that those clients deliver in a hospital. And so this is the kind of encouraging correlation, again, don't trust this, that we're hoping to see, which is that more time spent actually has like effect on the important behaviors that we're trying to drive. And then if that turns out to be true and validated from the field, that would give us a lot of encouragement to try to do things which would increase the number of home visits, the quality of home visits, because we think that we can monitor that right away, we can get quick feedback on whether the things we're doing to the system increase those behaviors, and we have some confidence that those behaviors are correlated, not necessarily yet. We wouldn't know at this point if they're causing the kind of behaviors we care about. So this is my last slide. I was asked to give some tips on analyzing and capturing data. And my thought was I don't really know how to do that, so instead I'm just going to give some reflections on how hard it is. And so the first reflection is it's really hard. And like we found, and I don't know if other people don't have this, but like whenever we have a big data set, we have the data, that can be a challenge itself. But even when you have the data and you start analyzing it, you get lost in exactly what the question you want to ask is. If you start doing exploration, you come back more confused than you started about what the data means. And then when you do a certain analysis, you're like, oh yeah, let's just go see these two things. Like that just raises more questions about how to analyze it. So I think that's natural, but just like I think it's important to like realize it's a long process, and you shouldn't expect it to go too fast. We found both in the big scale project and all the projects that we've worked on that if data isn't used, you shouldn't expect it to be high quality. So sometimes the data is used by the worker on the app, like they're registering their clients, they're tracking information that they see last time, so that's data they care about. If we analyze data, we care about it, so we might improve things, or if the supervisors look at data that gets followed up on. But for data that like isn't used by anybody, we found that when you finally look at it, it's of lower quality. Plenty of operational data gets collected for reporting purposes or other that really isn't used in a way that's meaningful in any way to the user collecting it. And then this may be obvious, but it seems worth stating that there's just a lot of judgments in how to analyze data. I think if you took any of our data sets and gave it to 3 different teams and asked even a well-formed question, like they'd come back with different answers, because there's how do you clean the data, exactly how do you analyze it. For that graph before, like we were interested in looking at behavior prior to birth. That data was sample data, but it was based on like a cutoff of 20 days before birth. But there's just like a million little judgment calls you make in the process of going from the actual data sitting in a spreadsheets to some kind of conclusions or graphs or tables, which I think isn't that's something wrong with that. But it's also good to kind of be aware of it, and then it influences. There's opportunities to add your own biases. There's opportunities to find attractive things in your data because you want to see good results. If I tried 15 days and it wasn't as good, maybe I would try 20 or something like that. And so it's just, I think, good to be careful of it. And then one, maybe the only actual tip is this last one. What we found, kind of based on all that, is what works well for us to kind of become data-driven, where we have been successful, is where we pick some indicators best we can and then stick with them for a while and look at them like every month. And then sometimes you want to revisit your indicators if they're not working for you. But what we found most useful is like to look at some data consistently and then like see the trends, went up or went down. That's usually something you can use to gauge how things are going. And then just be periodically go back and change your indicators, but don't always be doing kind of like new explorations and analysis. That's I think worked best for us over the years.
Okay, any questions for the speakers?
Thank you. And Neal, I especially liked the, I'm glad you didn't give us any examples. I'm glad you gave us that slide. It resonates with me. So I work for a large organization, BRAC, that is historically has a reputation for being a learning organization. But I can tell you as somebody on the inside, we are in fact, as has been said a couple of times, data rich and information poor. And I've often heard it said internally, God, if we just had some data analysts that, no, I'm being filmed right now, I hate this. Okay. I'm sharing too much, oversharing. Okay, thank you. I'm off the record. I've often suspected, I've often heard it said, you know, we really could use some data analysis experts that could tell us what to do with all this data that we're collecting. And I'm sure that's true on some level, and yet, what you said, I think it's right there, you know, if you have a lot of data and you're not using it, it's probably not very good data. And I've sort of, deep in my heart of hearts, I suspect that might be true with us. But, so that said, I guess my question for all of you is, for somebody in that sort of, in that situation, like where the heck do you start? If you were to take somebody in, a data analysis expert and parachute them in to my organization, I have doubts that that would really solve the problem very much.
Well, I'll take it
That's
first.
not an easy question.
And other people can focus. And I think I have a platitude of an answer, which is like, I agree. I think probably a team of expert data scientists might even further confuse the matter initially. And start small, give it a lot of time, look for small wins, and expect to find like lower quality data and higher quality data, and like expect to go like in those various figure eight loops we've seen all the time for your data use as well. So just like I'd say like having realistic expectations and kind of sticking with it. But I would expect like every month it would get better. Yeah, if you have people who could put a team onto it and a combination of data experts plus people who really know the programmatic data. I think that another failure mode is to let the data folks go too long on their own because they can dig into the data deep, but they won't have like the grounding of like what's programmatically realistic or important.
Just to add to that, I think the challenge is that you need to have an understanding of what are you trying to solve for. You have to have a specific problem, because typically what will happen is that the data guys can kind of just continue to analyze the data, but from a business perspective, we also have what we call business translators. So that if it's in, for example, in healthcare, we have someone who has a healthcare consultant. If it's economics, we have macroeconomics. We have economists. So you need what we call business translators, guys who have an understanding of both some aspects of the data as well as the business, because they can basically help you interpret what it is. So for example, let's say you might say finding the data that it's 1% growth. For GDP that is small, but if it's in healthcare, if it's a certain disease, then that 1% can be a huge impact, and thus it's very important to have a what we call business translators. But most importantly, you also need to have an understanding of what you're trying to solve for, because otherwise you can go down a rabbit hole.